Okay, let's go to do review problems. These are the problems that you can find at the end of your textbook, at the end of the chapter of chapter 1. So it's a list of the value which the given function is not continuous. Let's go to review what it means for a function to be continuous at a point x equal minus 3, for example. At x equal minus 3, for the function to be continuous must exist f of minus 3. The value of the function evaluated at f equal minus 3 should be exist. So the first condition is that f of x exists at the point. But in this case, f of x at minus 3 is 9 minus 1, 8, divided by 0. But 8 division by 0 is not allowed. This doesn't exist. So this function is not continuous at x equal minus 3. So this function is not continuous at x equal minus 3. What is the second thing that needs to happen? The second thing for a function to be continuous, the first thing is that must exist the value of the function at the point. The second thing is must exist the limit when h approaches 3 of x squared minus 1 divided by x plus 3. If you do this limit, it will be 2x divided by 1, it will be 6. So the limit exists. This limit will exist and will be 6. Sorry, the limit is the limit when x approach minus 3 of x squared minus 1 divided by x plus 3. This approach to 2x divided by 1, and this approach when x approach minus 3, this approach minus 6. Sorry, it approach minus 6. I will show you in chapter 3 how I do this limit easily. So the limit exists, but for this function, the value of the function at the point doesn't exist, so it's not continuous. So I was saying the three conditions. The first condition is that the function must exist at the point, the limit must exist, and the third condition is that the limit when x approaches minus 3 in this case, of the function f of x, x squared minus 1 divided by x plus 3, have to be minus 6, have to be this function, is minus 6 and have to be f of minus 3. In this case, f of minus 3 doesn't exist. So it's not continuous. These are the three conditions to happen. Let's go to the next. Let's go to do problem 50A. I will do part A, you will do part B. It's in each case, find the value of the constant A that makes the function to be continuous. So if I want to be the function continuous, at the point here, at this point, at x equal 1, the value of the function have to be glued. One part have to be glued with the other part. 2x plus 3 for x less than 1, 2x plus 3 when x equal 1, when x equals 0, this is 3, and the rectilinear line does like this, and when x equal 1, the function wants to be 5. Wants to be 5 when x equal 1. And the other function is ax minus 1. So I need that the limit when x approach 1 of ax minus 1 will be 5. So when x approach 1, this will be a by 1 minus 1 equal 5. So a should be 5 plus 1. So a should be 6. So if a is 6, the function is continuous. So I have the function 2x plus 3 defined for x less than 1. And I have the functions ax, 6x minus 1, for x bigger or equal than 1. Let's go to plug-in numbers. If x equal 1, from here the value is 5. If x equal 1, 6 by 1 is 1, 6 by 1 is 6, 6 minus 1 is also 5. So the function is continuous, and the function will glue perfectly with this function and will be another rectilinear line with another slope, will be like this, okay, with bigger slope. This have, the first one have a slope 2, this one have a slope 6, and the problem is done. Okay, this one, I don't know what is this one. Let's go to do this one, is x squared. I don't know what it say. Yeah, if it's continuous. It's not continuous at x equal minus 3 because it's not defined at x equal minus 3. Let's go to do this limit. When x approach minus infinity, x cubed minus 3x plus 5. When x approach minus infinity, the numerator plus 5 is equivalent to x cubed. Why? Because x cubed is more powerful than the term of x. So, and 2x plus 3, if x approach to minus infinity, adding a 3 or not adding is the same thing, so it's equivalent of 2x. So this limit is the limit when x approach of minus infinity of x cubed divided by 2x is the limit of 1/2 of x squared, is the limit when x approach minus infinity. When x approach minus infinity squared, it will be infinity, so there is no limit. The limit is infinity. There is no fixed number. So when x approach of minus infinity, the limit doesn't exist, meaning that the limit goes to the infinity. You can draw this picture, this graph, and you will see that when x goes to minus infinity, the limit goes to the infinity going. So the function will do like this, will do like this, will do like this, always in crescendo for this side. Indeed, is in crescendo if you walk in this direction. But normally you walk always to the right. When you walk to the right, is decreasing function, okay? You walk to the right, let me put a guy here. Let me see if I can put a guy. So, you walk to the right and the height will be smaller, and smaller is decreasing function. It's a decreasing function. If you walk to the left, the function looks to be increasing. But you always take the norm to walk always to the right. So if you walk to the right, the function is decreasing. Okay. Next problem is, this problem is the limit when x approach to minus infinity. So you say like this, when x approach to minus infinity, this is equivalent to make the limit when x approach to minus infinity of x to the 4 divided by x to the cube. But x to the 4 divided by x to the cube is x. So it's x. So when x approach to minus infinity, this approach to minus infinity. So the limit doesn't exist and approach to minus infinity. It means that if you graph this function and you graph it at minus infinity, the graph will go to the minus infinity. As you move To the left, the graph will be deeper and deeper and deeper. Okay. Let's go another one. Limit when x goes to infinity, to minus infinity of this function. The numerator is a smaller degree than the denominator. So you can do it like this. The limit when x goes to minus infinity of x divide x squared plus 5. If I have a big number and I add this 5, I have x squared. So it's the limit when x approach minus infinity of 1 divided by x. When x approach minus infinity, 1 divided by x approach 0. So this approach 0 minus. Oh, this is the limit. So how you can do it? You can do also, you put a big number, let's say 1000 divided by 1000. Sorry, a negative number, 1000, the minus 1000 squared plus 5, and you see if it approaches to 0. Later on, you put minus 10,000 divided by minus 10,000 squared, which is a positive number, plus 5. And you will see that it approaches more to 0. And goes, and you go. Okay. Whether it is the limit when x approach 1, x squared plus x minus 2, x squared, let's go to factor x squared minus x plus 2, so x squared plus x minus 2 is minus 1 plus minus square root of root plus 8 divided by 2. This is minus 1 plus square root of 9, that is 3 divided by 2. This is minus 1 minus 3 divided by 2. So this is minus 1 plus 3, this is 1. And minus 4 minus 2. So the expression, the polynomial, is this polynomial. This is x squared plus x minus 2. X minus 1 divided by x plus 2. Let's go to do the limit. So the limit when x approach 1 of x squared plus x minus 2 divided by x squared minus 1. When x approach 1, this is 0, the denominator. And this is 1 plus 1 is 2, 2 minus 2 is 0. So we don't know to where it will go, this form, when x approach 1. When x is 1, it doesn't exist, the function. It doesn't have any value. But when x approach 1, to what it approach the function. So we put the numerator as a factor, and we put here the factoring of x squared minus 1, which is x minus 1 plus x plus 1. And now we see that the x minus 1 cancel. So we have the limit when x approach 1 of x plus 2 divided by x plus 1. And this tends to 3, the numerator, and 2. So the limit is 3/2. You can do the data, and you can do the data means you put a number x equal 0.999999. Put it here. Put it here. Put it here, and make the calculation to see if it's 3/2. If not, I'm wrong. Or put a number equal 1.000001. That is a point that is very next to 1. So the point is 1. Here is the 0. This point is 0.9999991. And this point is 1.000001. So next to the point 1, there are 2 points. So when I approach into the point, the value should approach to 3/2. Try with your calculator to make the numbers to see if it happens. The other thing that you can do is graph the function in GeoGebra and see to what the function wants to be when you are approaching x equal 1. Okay, next, no more problem.